So as you guys are doing that, I've had a few questions over the last week or two of Mr. Smith. How can I improve my mark? How can I improve my mark? And oddly enough, the people that ask me those questions are the people that I'd have to remind to get on task, or who are shouting out the door at people walking by, or playing games on their phone while we're in math class. If in an academic level math class, you want to improve your mark, you got to be dialed in the entire class. You're dialed in, you're helping those around you. If you finish something worth marks, you're doing the stuff not worth marks. If you're finished that, you're reviewing your notes, you're making notes, or you ask for more stuff. So, if you have that question, Mr. Smith, how can I improve my grade? You can answer that yourself. But yeah, if you come to me and ask, just be prepared for me to have an honest conversation about how you do it. Most of it'll be stop doing this, stop doing this, stop doing this, and start doing this. Anyway, I digress. I'll catch up in a second. You guys slam out those 12 trig ratios. Some wild angles in there. 3,730 degrees. That's a lot of rotations. All right, I didn't name names, so we're still safe for YouTube so far. Please don't do shout outs in the middle of yes. You'll ruin my monetization scheme. What do we got? 0.766. Now, I've taught this lesson many times, so I'm pretty sure you guys got 0.766 for all of those four. Interesting. I wonder how those four angles are connected to each other. Is there some kind of relationship there? Who can say? Sine of 130, also 0.766. So these guys, I'll maybe double check just because those are big numbers. Maybe I did my math wrong. No, 0.766. 0.766. Tan of 410. Did you guys get 1.192 for the bottom row? No? What do you mean no? I just double checked. I got the same thing. Am I taking crazy pills, or did you guys get that same? The last one is tangent negative 310. No, I'm right. You're wrong. They're all. That is correct. At least for this time. All right. Discuss. I'll pause my video and let you guys discuss for another minute or so. Something is up here clearly, but there is a common relationship between each group of four. Each individual group are not related to each other, but there is a pattern in each row of four there. How are they connected to each other? I think I heard in some of your discussions, just listening, I think some of you guys see the connection. Does anybody want to share how they think these angles are related to each other? Michaela.
They're like the same rotation. They're just like going over more, like 40 and then 400 is 360 plus 40, 760 is 720 plus 40.
Exactly. Let's draw out the first group. I think we can draw the first group of four. So my fine motor skills are decaying with age, but your guys should be. Hi. Okay.
Thank you.
Very abrupt. All right, I think we can draw the first set of four angles out. I might save some room on the right for another set of diagrams, but let's do let's use the straight line tool while we're here. So 40 degrees, I think hopefully we'd all agree 40 degrees is somewhere, I'll get my pen tool. 40 degrees, somewhere about there, right? That first quadrant. So Michaela said, if we go from 40 and we just do a full rotation, 360 degrees around there. So we go all the way around like that. That is 400 degrees. We wind up at the exact same spot. Would you guys agree? The exact same spot. Now, if we did another 360 degrees from there, I can for sure add this on. So we're going to go for a little ride here. Once around and twice around and wind up here. So that is 2 full revolutions, 720 plus another 40, 760 degrees. And I think at this point, my diagram is getting a little clunky, so I'll stop there. But the idea is they all wind up at the exact same spot. And if they all wind up at the exact same spot, they're all related for that matter. They all have a reference angle of 40. And if they're all in the same quadrant, the cast rule says their sine, cosine, tan will all be the same sign. They're going to have the same trig ratios. Let's do one more diagram over here for the second pair. And I'm only going to add two, just to manage my space here. I think I'm only going to put 2 angles on here just to illustrate this idea. So 130 is somewhere around here. We can diagram this one. So 130 degrees, we go a bit past 90, we get to 130 degrees. If you draw negative 230 degrees, remember, that just means you go clockwise 230 degrees. If you go this way, 230 degrees, you wind up at the same spot. Why? Because 130 and 230 add to 360, right? And if we added 360 onto 130, we get the 490 you have there. So the idea is that these 4 angles in each group, they end at the same spot. So a fancy word for saying they end at the same spot. So share is like, or same, is like, I'm not sure if this is Greek or Latin, but that's what co means. Co means like you share. And fancy word for end is terminal. So the 4 angles in each group are called coterminal angles because they share the same terminal arm. They end up in the same spot. So let's jot that down. These guys are called coterminal angles. There you go. That's our new tech for today, coterminal angles. I got a lot of space for this definition. That's okay. I guess I'm using black now. We'll give my pink color a break. Coterminal angles, 2 angles that share. I'm going to put share in capital letters. That's the co part. The same terminal arm. Share, terminal. Coterminal. They end in the same spot. And if they end at the same spot, they're going to have the exact same trig ratios. They will have, I'm going to put this in caps too, since I have all kinds of space, identical trig ratios. Now there's we don't have to draw the angles out to figure out if they're coterminal or not. There's a numerical way, Michaela kind of touched on it. There's a numerical way to determine if angles are coterminal. This is kind of the big idea with coterminal angles. Coterminal coterminal angles differ by, they don't differ by just 360, although if two angles do differ by 360, they're coterminal. It's a multiple of 360. Differ by a multiple of 360. .360 So they could be off by 360 or 720 or 1080, hashtag 1080 snowboarding, or etc., etc. It just has to be a multiple. Why 360? Because you just rotate 360 and you wind up in the same spot. You get basically the same angle. That's the big idea to today. Let's play around with this. A little exercise. Can you guys find 3 positive angles that are coterminal to 70 degrees? So this kind of question shows what kind of person you are or how your brain thinks, because most people would be like, I'll just add 360 and then I'll add 360 again and I'll add 360 again. But my 8-year-old would be like, I'm going to pick some random number and add like 27 times 360, and he'll have to make me think about whether it's actually coterminal or not. But I'm going to keep things simple here. $70 plus 360, 430 degrees would be coterminal to 70. If I add 2 times 360, or I add 360 on top of 430, I'll have to be careful with my mental math here. I think that's 790. And you know what, guys? I'm going to go crazy here. I'm going to do 70 plus 13 times 360. So if you added on 360 again, psych, I'm going to do this. Whatever this number is, it's going to be big. 70 plus 13 times 360. 4,750 degrees. Yes, that angle would be coterminal to 70 degrees. That would be rotating 13 times and then an extra 70 degrees. Can you guys do that same exercise, but find 3 negative angles coterminal to 245? Simple little exercise here. So then I'm going to just improvise a question here. I don't recommend improvising when you guys start teaching your math courses. Something to chew on if you got 3 negative angles coterminal to 245. 120 and 22,800 degrees. Are those coterminal angles? I'll let you guys chew on that while I myself find 3 angles coterminal to 245. So I'm going to keep it simple for this one. I'm just going to subtract 360 a few times. Eight minus 835. Did I do that right? I think so. Minus 115, 360, 475, 660. Yeah, I think that's okay. So if you were thinking about whether 120 and 22,800 were coterminal, the inefficient way to go about that is to take 120 and to start just adding 360 and see if you get that number. That would take a while. The quicker way, and we're going to go back to our definition here, Coterminal angles differ by a multiple of 360. Well, what do these guys differ by? So humor me, guys, and subtract those two. 22,800 minus 120. So those angles differ by 22,000. So if you subtract these guys, 22,680. The question is that a multiple of 360? It's not?
Yes, it is.
I think if you divide that by 360,
Oh,
yeah, so divide that by 360, check if it's a multiple of 360. I think it's 63. Yeah. So those would be coterminal because they differ by a multiple of 360. You know what I see a typical misconception on a test would be students checking 22,800 and just dividing 22,800 by 360. You're going to get a decimal value, and students will say, no, it's 22,800 is not a multiple of 360. It doesn't matter. It matters that these two differ by a multiple of 360. So a little food for thought. That'd be a good communication question for your test. I basically give that as a communication question for your test. All right, let's continue. Hey, here's an exercise we did yesterday. We're just going to go one step further. Yesterday, you guys found two angles between 0 and 360 that had a specific ratio. So you guys already have lots of practice doing that, plus at least one from the warm-up. Now we're going to take it one step further. We're going to use our knowledge of coterminal angles to find four angles between 0 and 720 that have a cosine ratio of negative 0.5. I will walk through this one with you guys. First things first, what everybody should do is, using the cast rule, set up where am I looking for angles so that the cosine ratio is negative. You guys should be looking in your sine quadrant and your tan quadrant because cosine is positive in the cosine quadrant and the all quadrant. So we know we're looking for angles there. And our first step is always I'll even write this down. Our first step is always, hey, what does our calculator tell us? Our calculator can give us something helpful here. Inverse cosine of negative 0.5. Maybe it will even give us one of our angles we're looking for. I believe it does. Second cosine, if I turn my calculator on, second cosine, negative 0.5. 120 degrees. We've actually got one of our angles there. 120 degrees, we've got one. Yay us, that is one. How do we get the second, though? We did one of these yesterday. In order to find out what angle we have in the tan quadrant, we need the reference angle. Now, you guys can probably just do the mental math here. What's the reference angle for what? Somebody hasn't helped out yet today, perhaps? What's the reference angle? Okay, go ahead, Andrew.
60 degrees.
60 degrees. So now we're asking, what angle in the tan quadrant has a reference angle of 60 degrees? So we have 120 was our first one. Somebody who hasn't helped out today, let's share the load. Nina, I got you this time. The one in the tan quadrant. Or you can give me another one.
I don't even know why we're doing that.
Okay. So 120 degrees. So we're looking for an angle between 180 and 270 that has a reference angle of 60. Jordan's got it. 240. So I'm just going to write it this way. Our second angle, we'll take 180 and we'll add our reference angle, 240. We'll jot that down. And yesterday, you guys would stop there. You'd be done. You have two angles between 0 and 360 that have a cosine ratio of negative 0.5. But the U of today is going to find two more between 0 and 720. You don't have to think too hard. Somebody who hasn't helped out yet, how can we get some more angles between Madeline, go ahead. 360 more, right? Yeah, exactly. Take 120 and add 360 onto it. So I'm going to jot that down. How can we get another angle that has a cosine value of negative 1/2? We'll take 120 and add 360 to it. 480 degrees. Go away, menu bar. 480 degrees. And how do we get that fourth angle? Well, now that we have 240, take 240 and add 360 degrees. So just kind of what you guys did yesterday. To find more angles, keep adding 360. We can do it. And again, these questions are self-checking. If you could humor me and put in the cosine of 600 degrees, I'm 99.7% sure that it's going to give me negative 0.5. Of course it will, and it does. Negative 0.5 degrees. Self-checking. So I'm going to pass around some practice. You guys can try this last one. And we're going to have about half an hour of class time left. And I've only cooked up, I think, 4 more of these questions for practice because many of you guys, not many, some of you guys still have that assignment from last week. You could finish up. And I am going to, I would like it by tomorrow. And then some of you guys might have some things you want to add to your cheat sheet. I'm letting you guys use a cheat sheet this unit. So let me pass around a bit more practice, and I'll take this one up in a minute or two. Yeah. Once we take this one up, I'll distribute cheat sheets if you want it as well. I've already given these out.
I don't know what she ate the cat. Do you remember the cat? Oh, no. Do you remember the cat? You say this every time we bring up the cat. Remember when I ate like literally the cat the entire thing? No. Maybe no. Unless it was
Yep. Once we take this up, I'll drop it off.
Oh, that's where the code was. I was wondering where that went.
CAST.
No, it was not. I'm not surprised. I usually have no idea. When it was in the cat. But this is a place probably under like if I hit it once.
All right, guys, we're going to wrap this up. Everybody should be kind of drawing out where you expect to find your angles. Tan is positive in those 2 quadrants. Now, I usually cook these up to get a nice round number for the angle. What do we get here? 51. You guys get 51 degrees? So if I could just have a moment of your time, it's possible that you're rock solid and got this as well, but I'm pretty sure some of your classmates would like to follow along as well. So thank you for your cooperation. Since we're on YouTube, I'm not saying be quiet. That's my nice way of saying that. All right, so 51 degrees. Now that actually is one of our angles. It's the reference angle, but it's also one of the angles we need in the all quadrant. So it looks like we're good to go. So I might just jot this down for this one. The first angle we're looking for also happens to be our reference angle, 51 degrees. We can put that in our summary table. For our second angle, we're just asking what angle in the tan quadrant is 51 degrees past 180. We should be kind of old hats at this by now. Done lots of practice. So 231 degrees. Yesterday, you guys would have stopped there. The U of today can find 2 more by just simply adding on 360. So 411 and 591. I think no, definitely not. Yes, that's right. Is that right? 491, 591? Okay. A little bit of a brain fart there. I'm like, those are off by 180, but they should be off by 180. And again, this is you guys on your test. This is you guys. You think 411 is a solution. You check the tangent of 411 degrees. It takes 2 seconds, and you get the same ratio that the question required. Tan of 411. It doesn't take you guys any amount of time. It's just a nice self-check. All right. So when you guys are doing these 4 problems I've posed to you, I don't have solutions up yet. I might not post them because they're all self-checking. You can just check your answer by taking the sine, cos, or tan of your result. Okay. I've had a request for cheat sheets. I'm just going to hand out the ones I have and give everybody a blank one. Stop the recording.